In this lesson, we will look at eliminating boilerplate JDBC code with the Spring Data JPA inside of Jakarta Enterprise Edition 8. The key topics we will cover: we will understand how Spring Data JPA reduces our JDBC boilerplate code. We will set up Maven dependencies for our Jakarta Enterprise Edition 8 project. We will configure and create Spring Data repositories, and we will explore unified data access with Spring Data. Why it matters: it reduces development time through automation, it improves code quality, and it simplifies maintenance. Then we will dive deeper into what Spring Data JPA automates for us. JDBC requires manual connection handling, statement preparation, and result mapping. Spring Data JPA eliminates boilerplate, so we no longer have connection, prepared statement, or result set codes. It's got built-in transaction handling, and we can actually optionally manually manage that. Our CRUD operations come out of the box with interfaces like save, find by ID, and many more. And when we do custom queries, we need only the query logic. The mapping is handled for us automatically. Why it matters: it boosts productivity, it reduces errors, and it accelerates development. Then we'll look at configuring and creating Spring Data repositories. We will look at how we eliminate boilerplate code with the Spring Data JPA CRUD repository. We will configure JPA with Jakarta Enterprise Edition compatible components. We will define real repositories for our domain models like movie, actor, and studio. We will use these repositories directly in service classes to manage persistence logic. We do this to save time, to boost flexibility, and to focus on the business logic. Then we will look at Spring Data's unified data access, examine the unified API for querying and managing data with the Spring Data JPA. We will look at leveraging advanced features such as sorting, pagination, data transfer objects projections, dynamic queries, and query by example. We will learn how to simplify data access using CRUD repository and JPA repository, and we will efficiently integrate data retrieval with our movie, actor, and studio model. And why it matters: we get streamlined data access with one consistent API. We get improved performance with our sorting and pagination. We get better code organization by simplifying data formatting views, and we get enhanced flexibility with our dynamic queries. Now we are ready to go to our GitHub repo and look at the course documentation. And we'll look at Java Persistence API, eliminating boilerplate JDBC code with Spring Data JPA. We start with looking at the updated Maven dependencies. We've got Spring Data JPA. We've got Jakarta Persistence-api. We've got our logging SLF4J. We've got our Hibernate Core. Each of these are selected to be compatible with JDK 11 and Jakarta Enterprise Edition 8. And then we've got our MariaDB JDBC driver. So we look at our notes. The 2.7 is the last line of Spring Data compatible with Spring Framework 5.3 and Jakarta Enterprise Edition 8. before Spring Boot 3.x moves to Jakarta Enterprise Edition 9. Jakarta Enterprise Edition 8 still uses Jakarta Persistence with package names like Java x.persistence, but artifacts group IDs are now under Jakarta. This is something that often trips you up when you go the upgrade path from legacy step by step. So now let's just go over to Eclipse, and here is our Spring JPA project, and here is our Maven dependencies, and this is all selected to be in line with Jakarta Enterprise Edition 8. And now back to our course documentation. We've just looked at our Maven dependencies. So now we will look at configuring and creating Spring Data repositories. So this is how we eliminate the boilerplate code by using the CRUD repository. We'll start with a configuration, enable JPA repositories, where we set the data source, we set our Hibernate dialect, and we add a JPA transaction manager. Then we define our CRUD repository interface. So here we have movie repository 2, extends CRUD repository. We've got find by title, we've got find by studio name, and we've got find all with actors and studio. Then we have our studio repository, extends CRUD repository again. We have find studio name containing, and then ignore case like we had before. We have find by year founded. So these are provided for us in a CRUD repository: save, find by ID, find all, delete by ID, count, and many more. And now we integrate that with our service classes. We'll start with a movie service 2. We auto wire in our movie repository 2. We set a transactional save movie. We set a transactional read only, get all movies with details. And then we set a transactional read only search by title, which does the find by title. Then we have our studio service, where we auto wire in our studio repository, transactional create studio, transactional search studio by name, and transactional delete studio by ID. When we look at our summary with our CRUD repository, we can rapidly prototype JPA-based applications without writing DAO implementations. We can use derived queries and custom JPQL to fetch meaningful data. We can load entity relationship using an @entity graph to avoid N+ issues. And we can keep our service layer focused on business logic and transactions. And now let's continue to our unified data access. Spring Data JPA offers a consistent and powerful API for accessing and querying data. Once your repositories are configured, you can take advantage of advanced capabilities like sorting, pagination, data transfer, object-based projections, dynamic queries, and optional specifications, query by example. So here we look at some of the examples related to that. Spring Data allows you to pass a sort parameter directly into your query methods. So here you pass in the sort, and here is how you set up the sort by release date. So this is how you call it: find by genre, sci-fi, and then sort by release date. Then we have pagination, where we have find by genre with pageable. So here is our example. We specify pageable, sort by release date, descending, beginning and ending values. Here we do the find by genre, passing in the pageable. and then we get the list from the page.content. So these also work with our Spring MVC controllers. Then we have projections with data transfer objects. You can fetch flattened data using data transfer object projections, either via JPQL or Spring Data interface-based projection. So this is our example. We've got title and studio name. Then we have a constructor, and we can map it by get title and get studio name. Then we have our JPQL based projections where we do a query by title and studio name from movie and then fetch movie summaries. You can also use custom JPQL and native queries. So you're not limited to derived method names. You can write expressive JPQL or even native SQL if you need. So here is the query. Select new movie summary by title, studio name from movie, and then it gets applied to fetch movie summaries. You can also apply a dynamic filter, example of new movie, and then just avatar and find all by example. In conclusion, Spring Data Unified approach gives you sorting and pagination, data transfer objects for front-end friendly shapes, JPQL and native queries for complex data needs, optional pattern matching using query by example. And now we'll look at our example in Eclipse. We start with Movie App 2. We have our new annotation config application context. This is part of the Spring framework. What it does is it opens it to the class path of com.core designs config. And in here, we have our JPA config, our model mapper config, and our Spring config. So it will pick all of that up. And then we have our movie service 2. And here is movie save, find all with actors in studio, find by title containing, and fetch movie summaries by a sort. We go back. Here we do a fetch movies sorted by release date. So we do a movie service. We do a get movie summaries sorted by release date. And then we print all of that out. Here we pass in a sort of descending on release date. Here is our implementation. So let's run it. Run as Java application. And there it goes. Here is our fetching movies sorted by release date. Here is the output of our SQL with Hibernate. And here is our 2 movies sorted by release date with the latest one first. Once again, the rest is for self-study. You've seen all the ways you can sort and page it, play around with it, and see what you can do. And that concludes this tutorial. I will see you in the next one.